Hello folks, it's Clinton Moss here with Gunnar Energy Services. I have another little case study today that involves rotating magnet. Now I know I've made videos on rotary magnet before and you guys can go and look them up here on my YouTube channel or on LinkedIn, but let me just give you a brief overview. So remember, rotary magnet contains two primary elements. You have the directional drilling BHA that has between the bit and the bit box a rare earth magnet sub. As the bit spins, it creates this huge magnetic field in all dimensions around the bit. Now, in an offset well, okay, cased or open hole, you deploy the sensor. The sensor is deployed at approximately the same or closest point to the well that you're drilling, and that gives you that bearing, the distance and direction now from the drill bit to that offset well. So now that I've reminded everyone how rotary magnet works, let's go down hole. I want to show you one of the challenges of a deployment where a horizontal well is intersecting a vertical and how we solve that challenge. Okay, folks, let's go down hole and check it out. So here we are down hole, folks, and let me set this up for you. So you can see now in the distance we have the horizontal directional drilling assembly, and it has contained within it, between the bit and the bit box, the rotating magnet. Now, look over here where we see the vertical well, okay? It's partially cased down to a certain point, but then there's an open hole, a barefoot section that's left, okay? And we use that open hole to position our probe. The thought being, when the probe is in a vertical well, we want it to be free of magnetic interference for two reasons. First, we don't want the rotating magnet signal to be attenuated or distorted in any way. But more importantly, if we're vertical, if the sensor is vertical, it has no way to determine its orientation in space. That is to say, it can't figure out what its tool face is. Now, why is that? Well, it can't determine a high side tool face because the tool is not inclined. It is in fact vertical. The high side tool face is undefined, okay? What about a magnetic tool face? Well, you can see I'm in open hole, so it should work, right? Not so fast. This casing, okay, the casing that goes partially the way down, it has its own magnetic field, as you see now. That magnetic field from the casing is superimposed over the Earth's field, Earth's present, and it could confound or confuse the tool so it can't properly determine magnetically what its orientation is, what its tool face is. So what would happen, folks, if we were trying to detect this rotary magnet signal with a probe that is confused about essentially what way it's pointed, okay? It's going to give you an improper direction to target. Now, if we're drilling horizontally and approaching the vertical well, we must have the proper direction to target, or we'll aim at the wrong point in space and we won't intersect. How do we cure this issue? Well, it's pretty simple. We put an inline gyro, a gyro that's fully incorporated into the wireline assembly. That way, folks, when we want to take a ranging measurement, the first thing the tool does is determine its orientation in space with a gyro measurement that's not affected by magnetics. Then it receives the magnetic signal, processes properly the distance and direction to target, and that way we can home in and intersect that target well. So there you have it, folks. A quick little addition to our portfolio, this ability to run an inline gyro, which cures all these issues with a vertically deployed tool. For all your magnetic ranging needs, folks, one call does it all. Call Gunnar Energy Services.